Our staggering lead is way off the charts, 390 light-years away. Honestly, for setting 1 light-year is indistinguishable from 6 trillion miles. In humanity's relentless mission for loosening up the secrets of the universe, we've set out on a mission that goes past time itself, searching for answers to age-old questions woven into the fabric of existence. The James Webb Space Telescope, with its unblinking eye, has actually recognized a brief glance at a structure starting before the formation of stars. This brilliant object appears to be more ancient than the universe itself, raising more questions than it answers. How might a plan exist that begins before our universe? Or is the hypothesis of how things came to be to blame? Join us as we embark on an odyssey directed by the discoveries of the James Webb Telescope. The mysteries of a 13.8 billion-year-old cosmos await, and the journey to unravel these colossal secrets has just barely begun. In a faraway corner of the universe, around 200 light-years away, an old star called HD 114283 lives close to the Libra constellation. This eminent pioneer moves vigorously through space, offering entrancing looks into its violent past. Precisely, quite a while back, when our Milky Way was still in its infancy, it ingested a dwarf galaxy that once called it home. But what truly piques our infinite interest in HD 114283 isn't its rapid interaction, it's its astounding age. Among the celestial bodies we've observed, it remains one of the oldest, earning the enchanting moniker Methuselah star, compared to the biblical figure Methuselah, who supposedly lived for quite some time. Initially estimated to be a shocking 16 billion years old, the latest estimates suggest a somewhat younger period of 14.46 billion years, with a margin of error of 0.8 billion years. This revelation about its age confounds astronomers. After all, the age of the universe, calculated from the cosmic microwave background, floats around 13.8 billion years. This discrepancy raises critical questions about the star's age, the universe's age, and even the accuracy of our dating methods. Let's break it down. Figuring out the age of celestial objects can be a veritable enigma. Take stars, for instance. Like the sun, they're similar to immortal lights, maintaining their luminosity, temperature, and size for billions of years, making them fascinating to age date. Space scientists use changes in brightness and color as indicators, comparing these with models predicting how stars evolve over time. One age giveaway is how fast a star spins, like a wheel slowing down over time. Stars do this too. By contrasting the rotational speeds of stars at various ages, cosmologists have sorted out a neat trick called gyrochronology. Stars also spill their age secrets through magnetic chatter, flares, and ejections of energy from their surfaces, resembling a star's energetic excitement. Astronomers, being the space analysts they are, use advanced techniques like astroseismology. It's like listening in on a star's internal conversations, focusing on vibrations caused by waves moving through its interior. These vibrations reveal the star's age. For instance, applying this vast eavesdropping, scientists have timed the sun at 4.58 billion years. Now, back to Methuselah star. The old radiation around it isn't random. Astronomers labeled it with an old age by looking at its elemental makeup. Stars can be classified into groups based on how much metal or heavy elements, like iron, they possess. Our sun is somewhat of a metalhead, belonging to population 1 stars. Methuselah star, on the other hand, resembles an ancient relic from population 2, sporting fewer heavy elements. It's the cosmic equivalent of being a galactic archaeologist, unraveling the age stories of these celestial beings. Now imagine a collection of stars, the theoretical population 3, which scientists believe might be the universe's most extraordinary gems. While they're still hiding in the background and haven't yet appeared in our telescope spotlight, cosmologists suspect these stars might be the legends of creation, containing virtually no heavy elements. To grasp the grand scheme, we must rewind to the universe's early days after the Big Bang. Picture an infinite kitchen filled primarily with hydrogen and helium, the universe's essential ingredients, around 92% hydrogen and 8% helium, or if we weigh them all together, 75% hydrogen, and 25% helium. In this cosmic symphony, the main performers on stage were the population 3 stars. They were massive and hot, burning through their fuel rapidly, converting hydrogen and helium into heavier elements. When these early astronomical giants exploded, they spread these heavy elements into the vast void. In line were the population 2 stars, forming a bit later but in the universe's early days. Their original materials were laden with heavy elements, particularly iron. Many of them lived their stellar life cycles, exploding into supernovae and adding more heavy elements to the cosmic mix. Eventually, the population 1 stars, including our Sun, emerged as cosmic newcomers, forming from advanced gas clouds mixing with remnants from the earlier population 2 stars. Now the central question: does this vast story throw a cosmic curve at the theory of the ancient Big Bang? It's a head-scratcher. But here's the twist. There's a 70% chance that Methuselah's star, the ancient cosmic wanderer, could be around 13.66 billion years old, aligning with the universe's age. There's also a 30% chance that this old cosmic wanderer's age is playing outside the astronomical rulebook. In much the same way, there's a 15% chance it's not quite as old, but significantly younger. Imagine rolling a standard 6-sided die and hoping for that tricky 6. Statistically plausible, right? Regardless of what these cosmic twists throw at us, what's certain is that Methuselah's star isn't just an old veteran, it's the granddaddy of stars. We've managed to give it an age label that is remarkably precise. Now here's where it gets fascinating. Instead of scratching our heads about whether Methuselah's star could be 2 or 3 billion years older than its enormous neighbors, we should flip the cosmic script. What if the universe itself isn't as young as we once thought? Understanding 13.8 billion years is like trying to grasp the enormity of space itself. If we transform the entire history of the universe into a cosmic calendar, with the Big Bang as the most massive New Year's fireworks, Earth wouldn't join the cosmic parade until the final seconds of December 31st. Human history, that is just a blip in time, covering only the last 10 seconds. Our cosmic examiners determine the universe's age by looking at old starlight born a few 100 million years after the Big
Bang.
As the universe expands, it gives this light an infinite makeover known as redshift. Doing the math on both distance and expansion, astronomers declared an overall age of 13.8 billion years. But hold tight, because the cosmic narrative starts to get intriguing. A recent buzz from the University of Ottawa suggests the universe might be an incredible 26.7 billion years old. Professor Rinder Gupta draws on a theory from 1929 made by Swiss astronomer Fritz Zwicky, and it's shaking up our astronomical understanding. This theory throws a curve, suggesting that as light particles, photons, traverse the vastness of space over time, they lose some of their energy. Although this idea doesn't perfectly align with what we've observed through our telescopes, Gupta proposes a cosmic compromise. He suggests we can blend this theory with our current understanding of an expanding universe, creating a sort of hybrid explanation for the redshift phenomenon. Now strap in, because changing the universe's age to an astonishing 26.7 billion years is no small feat. Gupta adds another twist to the cosmic mix by combining light scaling theory with evolving coupling constants, a brainchild of theoretical physicist Paul Dirac. This concept proposes that how particles interact may have changed over time. And hey, researchers have a history of tweaking the cosmic clock. In the 1920s, Edwin Hubble thought the universe was only a simple 2 billion years old. We've come a long way since then, refining our astronomical math, and doubling the universe's age feels like taking a giant leap in our cosmic view. But let's pause for a moment. Whether this new perspective becomes the cosmic norm is still up in the stars. Whether humanity's written history is a mere blip of 10 or 5 seconds in the grand scheme of the universe, one thing's clear. The universe is a treasure trove of ancient wonders and endless inspiration. Shifting our gaze to our cosmic backyard, the Milky Way, there's a stunning cosmic dance unfolding. Recent estimates hint that stars on the edges of our galaxy are strutting their stuff in slow motion compared to their partners in other galaxies. What's the cosmic scoop? Well, there are several hypotheses, and one whisper is that our Milky Way might be running dangerously short on an invisible massive ingredient called dark matter. This elusive substance influences the gravitational dance of celestial objects. There's a cosmic riddle involving dark matter, the mysterious substance we can't see but seems to play a gravitational tug-of-war in the universe. One possibility shaking our cosmic understanding is that perhaps we've been measuring dark matter incorrectly. Our universal compass might be pointing askew. Here's where the European Space Agency's Gaia satellite steps into the cosmic spotlight. It's like our astronomical expert providing complex insights into the dance of nearly 2 billion stars in our Milky Way. Think of it as an astronomical census. The satellite's precise measurements have led astronomers to reevaluate their grand cosmic notes. Stars at the outer edges of our Milky Way appear to be moving more slowly than previously thought, challenging our old assumptions about their velocities. How do star speeds reveal the cosmic secrets about a galaxy's structure? It's like examining the size of a galaxy's gravitational influence. If stars on the outskirts are lagging behind, it could suggest that our galaxy is experiencing a gravitational pull from dark matter that we've underestimated. This insight into star velocities may indicate that our Milky Way is not just a solitary island in the vast universe, but part of a larger cosmic web influenced by dark matter. The Gaia satellite's data could provide the clues we need to understand this invisible component better, offering a clearer picture of how galaxies interact and evolve over cosmic time. As we delve deeper into these revelations, we are reminded of the complexities of the universe and the mysteries that still lie ahead. With tools like the James Webb Space Telescope and the Gaia satellite, we are better equipped than ever to explore the cosmos, peel back its layers, and perhaps answer the most profound questions about our existence. In this grand journey, the universe remains a treasure trove of ancient secrets, waiting to be uncovered, challenging our understanding and inspiring us to continue our quest for knowledge. Whether we're unraveling the age of stars, the dynamics of galaxies, or the elusive nature of dark matter, each discovery adds another piece to the cosmic puzzle, revealing a universe far more intricate and awe-inspiring than we ever imagined. As we look to the future, the mysteries of the cosmos beckon us onward, inviting us to explore, question, and expand our horizons, reminding us that the quest for understanding is as vast as the universe itself.